Regular expressions are probably one of the most powerful text processing features of JavaScript, and that's the subject of this particular chapter. Regular expressions have been around for a while. If you've ever used a programming language like Perl or some others, you've probably come across regular expressions. But let's start at the beginning and talk about what regular expressions are. Essentially, regular expression is an object that describes a pattern of text characters. And you can see some common patterns here. For example, there's U.S. postal codes, which are 5 digits, followed by an optional dash and 4 more digits, which is supposed to help the post office get mail to my place faster, which I'm not sure if it ever actually works. There's email addresses of the form, a bunch of characters, followed by an @ sign, followed by some more characters, followed by dot something. .net, something like that. Another common pattern is ISBN numbers. These are used in the publishing industry to identify books and where the book came from, and that kind of stuff. ISBN numbers have this pattern here. So patterns are pretty common throughout the programming world. They pop up all the time. And chances are, if you've ever had to build script that validates form fields or works with data in some way, you've come across the need to process text patterns. That's where regular expressions really shine. Using regular expressions, you can perform all kinds of searching and manipulation operations on text that would otherwise require very complex pieces of script. And I'll show you what I mean in just a moment. Regular expressions are created using either the regexp object or using a special literal syntax inside your script. And we'll get into that in a minute, but I thought it would be instructive to see the relative power of regular expressions by taking a look at solving a common problem and then solving the same problem using a regular expression. So let's jump over to the code and take a look at what I'm talking about. Okay, so here I am in the code. I want you to imagine for a moment that we had a requirement in our script to take a string of characters and write a function that makes sure that the string only contains alphanumeric characters. That is, lowercase a through z, uppercase a through z, and the digits 0 through 9. Now, if you were to write that using regular script like I've done here, you can see that it's not a trivial thing to do. I have a function here called test_only_alphanum. In fact, what I should really do is name it, according to my Hungarian notation, is b test_only_alphanum because it returns a Boolean. And I'm going to name the same thing down here in the onClick handler. I'm going to alert b test_only_alphanum. So let's take a look at what the function does. It takes a string as an argument. And if the string's length is 0, well, then obviously it doesn't contain any alphanumeric characters. So that's a false right away. But if it does have characters in it, what we need to do is loop over every one of the characters and see if any one of those characters is not an alphanumeric one. And if any of those characters are not alphanumeric, we can immediately return false. So here we have a loop, and the loop starts at 0 and loops over all the characters in the string. And for each character, we extract the character code at the position where the index currently is. And then we test each character code. So 48 and 57 correspond to the numerical digits 0 through 9. 65 and 90 correspond to uppercase a through uppercase z. And 97 and 122 correspond to lowercase a through lowercase z. So if any one of the characters in this string is outside any of these ranges, we know immediately that we don't have a string that only has alphanumeric characters in it. If we make it all the way down here, however, then we passed all the tests and the string has only alphanumeric characters in it, and we can return true. So let's test this out in the browser and see what happens. So I'm going to type in ABC123. I'm going to test. Okay, and that's true. Looks like we've only got alphanumeric characters there. I'll put in some capital ones. Okay, so far so good. Let's put in an exclamation point. Oh, now it's false. Yeah, that's not an alphanumeric character. What happens if I put a space at the front? Yep, that's also a problem. Okay, so it looks like the piece of script that we've written does a pretty good job of detecting characters that are not alphanumeric. But I want you to watch what happens when you use a regular expression. Using a regular expression, I can replace all of this code right here with the following line. I'm going to return str2 test dot match is not equal to null. And what I'm going to match it against is inside these two slashes, I'm going to type an upper hat character and then A to Z, uppercase A to uppercase Z, 0 to 9, close bracket, plus $sign. Now, don't get freaked out by what I'm typing here. This is not some really hard to understand code. We'll cover this in following examples, but what I'm defining here is a regular expression that matches lowercase letters, uppercase letters, and digits starting at the beginning of the input and at the end of the input. That's what these two characters mean. So now I'm going to comment all of this out and just run this example using that one line of code. So we're going to browse this. Up it comes. ASD, 1, 2, 3, some capitals. Okay, you can see it matches the rules of the game. Okay, now let's put some other stuff in there. Let's put like a $, test that. Oh, nope, that fails the test. Let's put in 0 and a dash and 1. Oh, that fails the test too. So you get the idea. Basically, what I've done is, let's go back to the code. You can see I've replaced all of these lines of code with this one line of code right here. And all it's doing is taking some pattern that I've defined and matching it against the string and returning whether or not that's equal to null to see if there's a match. So that's the power of regular expressions. And now that we've seen it in action, let's go back and see how we define these and how we work with them.